Preparing for a SRE at LinkedIn interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define and use SLIs, SLOs, and SLAs for a critical LinkedIn service? An SLI measures user visible behavior, an SLO sets the target, and an SLA adds an external commitment. For a feed service, I might measure successful feed loads and P99 latency, then define a 99.95% monthly availability objective. The error budget becomes the difference between 100% and that target. Teams can spend it on releases or experiments, but pause risky changes when it is exhausted. I would review objectives against real customer impact rather than choosing arbitrary numbers. While answering, distinguish measurements from objectives and commitments, discuss availability, latency, error rate, user journeys, percentile targets, error budgets, and how SLOs guide release and reliability decisions. Question 2. How would you troubleshoot a sudden increase in P99 latency for a LinkedIn API? I would first confirm the increase is real, scoped correctly, and not a monitoring artifact. Then I would compare P50, P95, and P99 across regions, endpoints, versions, and dependencies. Distributed traces can expose database, cache, or downstream delays, while saturation metrics reveal CPU, connection pools, or thread queues. I would mitigate through rollback, traffic shifting, caching, or capacity expansion, depending on evidence. After recovery, I would document the timeline and add a regression test or alert. Make sure to cover symptom confirmation, dashboards, traces, recent changes, dependency latency, saturation, traffic patterns, rollback criteria, mitigation, and follow-up actions that prevent recurrence. Question 3. Design a highly available service for LinkedIn profile reads across multiple regions. I would deploy stateless read services across multiple regions behind latency-aware global routing. Profile data would use replicated storage, with a clear decision between strong consistency for sensitive updates and eventual consistency for ordinary reads. Health checks should test meaningful dependencies, not merely process liveness. During regional failure, routing shifts traffic while rate limits and caches protect surviving regions. I would define RTO and RPO, rehearse failover regularly, and verify that stale data remains acceptable to users. In your answer, discuss replication, consistency choices, traffic routing, failover, health checks, data placement, recovery objectives, graceful degradation, and how you would test regional outages safely. Question 4. What is an error budget, and how would you use it during a high-risk release? An error budget is the tolerated unreliability implied by an SLO. A 99.9% monthly availability target permits roughly 43 minutes of failure. Before a high-risk release, I would check recent burn, dependency health, and the change's blast radius. If sufficient budget remains, I would canary gradually with automated rollback thresholds. If the budget is depleted, I would prioritize stabilization and postpone risky work. The goal is not perfect uptime, it is an explicit, shared trade-off. Be sure to mention the mathematical relationship to SLOs, budget consumption, release gates, rollback automation, business context, exceptions, and balancing feature velocity with reliability. Question 5. How would you design monitoring and alerting for a Kafka-based event pipeline? I would monitor end-to-end event age, consumer lag, producer error rates, throughput, broker disk and network saturation, under-replicated partitions, and consumer processing latency. Lag alone can be misleading if traffic is low, so I would alert on time to process and projected recovery time. Dashboards should separate symptoms from causes and include topic, partition, and consumer group dimensions. For failures, I would use retries with bounded backoff, dead letter handling, and alerts based on lost or delayed business events. Focus on producer and consumer health, throughput, lag, latency, broker capacity, replication, rejected messages, dead letter handling, actionable thresholds, and alerts tied to customer impacting SLOs. Question 6. Explain how you would perform a safe database schema migration on a heavily used service. I use an expand and contract approach. First, I add nullable fields or new tables without changing existing behavior. Next, application versions write compatibly, and a controlled backfill populates new data while monitoring database load. I validate counts and sampled records before switching reads behind a feature flag. Once every consumer is migrated and stable, I remove the old path in a later change. Because destructive migrations are difficult to roll back, I separate them from deployment and retain recovery backups. Cover backward compatible changes, expand and contract migration, dual reads or writes, backfills, validation, feature flags, throttling, rollback limitations, and monitoring during each phase. Question 7. How do you distinguish a Kubernetes liveness probe from a readiness probe? A readiness probe answers whether a pod should receive traffic. A liveness probe answers whether the process should be restarted. I keep readiness sensitive to initialization and required serving dependencies, but avoid making liveness depend on every downstream system, which could restart healthy pods during an outage. For slow starting applications, I add a startup probe to prevent premature liveness failures. Poor probes can create restart storms, so I test thresholds and observe behavior during dependency failures. In your answer, explain restart versus traffic removal, dependency checks, startup probes, failure modes, probe design, cascading failures, and examples for a production service. Question 8. Describe your incident response process for a production outage. I first acknowledge the incident, assess customer impact, and establish an incident commander. Separate roles handle investigation, mitigation, communications, and documentation so the team stays coordinated. I prefer reversible actions such as rollback, traffic reduction, or disabling a feature before pursuing a perfect root cause. I provide predictable stakeholder updates and escalate early when impact grows. After recovery, I verify service health, write a blameless timeline, identify contributing conditions, and track corrective actions to completion. Mention detection, incident command, roles, communication, severity assessment, mitigation before diagnosis, status updates, escalation, recovery validation, and a blameless postmortem with measurable actions. Question 9. How would you prevent cascading failures when a downstream service becomes slow or unavailable? I would give every dependency a bounded timeout aligned with the caller's own latency budget. Retries should be limited, use exponential backoff and jitter, and occur only for safe transient errors. Circuit breakers stop repeated calls during failure, while bulkheads isolate connection pools or worker capacity. I would shed optional work, serve cached or partial responses, and cap queues to avoid memory exhaustion. The design must expose dependency-specific metrics so operators can distinguish protection from hidden data loss. Discuss timeouts, bounded retries, exponential backoff with jitter, circuit breakers, bulkheads, load shedding, fallback behavior, queue limits, dependency budgets, and observability. Question 10. What makes an alert actionable, and how would you reduce alert fatigue? An actionable alert signals a meaningful risk, identifies the affected service, names an owner, and suggests the next step. I prefer alerts on slow burn rate or customer symptoms, supported by diagnostic dashboards, rather than every CPU fluctuation. I reduce fatigue by deduplicating related failures, assigning severity, tuning thresholds from historical behavior, and deleting non-actionable notifications. Each alert needs a tested runbook and review after incidents. If nobody would respond, it belongs in a dashboard instead. Be sure to cover user impact, symptoms versus causes, severity, ownership, runbooks, deduplication, aggregation, thresholds, alert testing, and removing notifications that do not require human action. Question 11. How would you run a blameless postmortem after an incident caused by a bad deployment? I would describe what happened without labeling individuals as careless. The document would include customer impact, a precise timeline, detection and mitigation steps, and contributing factors such as weak tests, deployment coupling, or unclear ownership. I would ask why safeguards failed at each stage rather than stopping at human error. Actions should be specific, prioritized, assigned, and measurable. For example, automated canaries or rollback checks. Finally, I would review completion and confirm the new controls work in practice. Focus on factual timeline, customer impact, detection and response gaps, contributing system conditions, psychological safety, specific owners, deadlines, prevention, and verification of completed actions. Question 12. How would you design capacity planning for a rapidly growing LinkedIn service? I begin with demand drivers such as requests, active users, event volume, and traffic seasonality. I correlate them with saturation metrics and identify the first bottleneck, whether compute, storage, database connections, or network. Capacity models should include peak forecasts, safety headroom, provisioning time, and failure scenarios. I validate assumptions with load tests that resemble production traffic, then automate scaling where possible. I also track cost per request because unlimited capacity is not a practical reliability strategy. Cover demand forecasting, resource saturation, workload modeling, headroom, seasonality, cost, autoscaling limits, bottleneck identification, load testing, and capacity plans tied to reliability objectives. Question 13. What is the difference between a canary deployment and a blue-green deployment, and when would you choose each? A canary sends a small, controlled percentage of traffic to the new version, allowing comparison of errors, latency, and business metrics before wider rollout. Blue-green maintains two environments and switches traffic between them, enabling fast rollback but requiring duplicate capacity and compatible data changes. I choose canaries when gradual risk reduction and statistical observation matter. Blue-green fits simpler, independently deployable services needing rapid cutover. Either strategy requires automated health checks and rollback criteria. Explain traffic exposure, infrastructure requirements, rollback speed, observability needs, database compatibility, cost, risk profile, and a LinkedIn scale example for each deployment strategy. Question 14. How would you secure secrets and service-to-service access in a production platform? I would avoid embedding secrets in source code, images, or static configuration. Workloads should obtain short-lived credentials through workload identity or a centralized secret manager, with least privilege policies and automatic rotation. Secrets need encryption in transit and at rest, audited access, and careful redaction from logs and crash reports. I would test revocation and recovery procedures, scan repositories and build artifacts, and separate production access from developer access. Security controls must remain observable without exposing sensitive values. Mention centralized secret management, short-lived credentials, rotation, least privilege, workload identity, encryption, audit trails, prevention of leakage, access reviews, and emergency revocation procedures. Question 15. How would you improve reliability for a service that has frequent but individually small incidents? I would aggregate incidents by symptom, root cause, service, and customer impact instead of treating each event independently. Then I would compare slow burn, engineer time, recurrence, and prevention cost to prioritize the reliability backlog. Common improvements might include safer deploys, better timeouts, capacity automation, dependency isolation, or self-healing workflows. I would measure mean time to detect, mitigate, and recover, but also recurrence rate and toil hours. Reliability work is successful when incidents become less frequent and less expensive. In your answer, discuss incident trends, toil measurement, recurring failure modes, reliability backlog, automation, dependency analysis, slow impact, prioritization, and proving improvement with operational metrics. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.